can see again the orbital mechanics in effect as these stars begin to dance around a binary black hole system. Nope. That got noped. This one's getting noped. Left and right. Now what are these remnants here? I can't really click on them. There's something so eerie yet not eerie yet compelling. I don't know what it is. Oh, look at these. We got. Wow, what the hell just happened here? Are these two stars that just exploded, or where did this nebula come from? What's going on? Welcome back to the universe, Sandbox. Our universe simulated. I hope you guys are ready for this one. So, go brush your teeth, put your pajamas on, lay down, pop some headphones in, shut off all the lights. Make sure the AC is nice and cool. Or maybe that's a Florida thing. Maybe you want it nice and hot if you're up north in the wintertime. But either way, I want you to get very comfortable, because we're about to explore black holes. And what you're looking at right now, is a simulation. If I were to have put the black hole known as Sagittarius A star at the distance of roughly Neptune in our solar system, you're looking at what would have happened to the rest of the objects in our solar system. All of them there, way in the background. Here they are through the gravitational lensing effect. I didn't know whether to put an ing on the end of gravitational lens, but let's see, I can latch on. So what had happened here? I'm still so amazed by the three-dimensional effect of this simulation. But what had happened here was they were ejected due to they were ejected rather immediately due to the immense incredible gravitational attraction of the black hole in the background there. Now, I'm not quite sure why they haven't already begun on an elliptical orbit back around, but some black holes. What we know about them. Some of the categories of black holes. Let's see. Let's put one. Sagittarius. Jesus. It's 4 million suns. Sagittarius A is the black hole at the center of our Milky Way. So let's just go ahead and put one right here. We'll start off. That's how do I, as you can see, my font ratio is quite large, so you guys can see exactly what it is I'm doing right now. Let's see if I can get rid of that name. Anti-aliasing texture. Video. Oh, cool. I guess I can capture a GIF. That's neat. Oh well. Maybe it's dynamic. So black holes are some of the strangest and most fascinating objects found in outer space. And what we're going to do, they're objects with extreme density. We're going to go ahead and put our sun, which is a yellow main sequence star. Oh my god. That immediately was tore up. There's not much left. Man, I really want to get rid of that text. Oh, here we go. Harvard's labels, nice. Wow, it's really not being eaten as quickly as I thought it would be. Look at this. This is amazing. Also, there's fragments of it coming back. So it appears that the sun is still... Sorry, oh, there, it's like the sun is still maintaining some of its integrity. Sorry, maybe I should have picked a dimmer star. I'm not trying to give you guys any epileptic shocks. Albert Einstein first predicted black holes in 1916 with his general theory of relativity. The term black hole was actually coined much later in 1967 by the American astronomer John Wheeler, and the first one was discovered not long after, in 1971. Black holes are a kink in the fabric of space-time. They're where... Oh, wow, it's speeding up. They're where an object or a center of mass has become so dense with so much mass in such a small volume, such a small area of space, that a singularity is created. Now what we're going to do here, we're going to add a new, larger black hole. So forgive the somewhat non-fluid, non-Newtonian fluid narrative structure of this episode. I'm trying to bounce back and forth between the game here and a few articles about black holes that I have readily available. Okay. Geez, that's way larger. So we're gonna put it 2 angstroms. No, sorry. Astronomical units. And look at that, it immediately goes careening towards the black hole. Wow, did it just get swallowed up? Or did it just get ejected into space? Either way, let's give you guys something to visualize while I track down here we go, the rest of the black hole articles. Oh yeah, this hole is definitely Sagittarius A star is absolutely moving with respect to the coordinates of this game. Oops, I didn't mean to do that. I guess once I click the left mouse button, I'm committed to planting that star at the location I clicked. Let's put a few at some other distances. Let's go way out. And then 2 in here too. So now we can see. Wow, you can see the tidal forces, particularly particularly on these guys. But even these ones, as the gravitational pull is so extreme that even from one side of this star to the next, there's a differential, meaning that there's more gravitational acceleration on this side, the inside of the star, than there is on the outside of the same star. So that the velocity, the force felt, is actually different depending on which side, the near or the far side of the star you're on. Let's try to give a more three-dimensional view. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9 stars. There are 21 times the mass of our sun, our star, being herded, gravitationally herded by the black hole at the center of our Milky Way galaxy. When Einstein developed relativity theory, it took him about 10 years to work out the math using a daunting form of mathematics called tensor calculus. He was only able to approximate the solutions to his own equations, and the math still perplexes even the best scientific brains. However, the challenge did nothing to deter one of Einstein's contemporary astronomers, a theoretical physicist named Carl Schwarzschild. Schwarzschild was Schwarzschild, a very consonant-rich last name, was a practical individual by nature. He pioneered new methods for studying spectra, for example. But he excelled in his abilities to deal with the theoretical concepts, and when Einstein's articles on general relativity were published in 1915, Schwarzschild was one of the first to recognize, well, let's put Beetlejuice here, to recognize their importance. Oh my god, Beetlejuice is huge. This is like just a massive star. I just put right in the path of the black hole, equivalent to 4.3 million times the size of our star. You can only imagine what happens here. Okay, I might have to put rings. I can put rings. No, that's weird. Let's put another Sagittarius right here. Oh, this is gonna get interesting here. You can see it right off there in the distance. The gravitational equations, the dynamics between these forces here are going to get very interesting. But what's even more interesting is that these are mere simulations, vast oversimplifications of phenomena that we have actually observed, not necessarily with visible light. Although I believe we've done it with that too, but oh, look at that, the star is getting ripped apart by both black holes. It's getting much closer too. Oh wow. Okay, let's back away before we get roasted. Oh. Is that really what happens, Universe Sandbox? So that's what happens. I like how their equations just nope. Those equations. Those stars are getting noped. Very, very noped. Noped so hard. It's like the programmers for this game were just like, they probably took a look at this tensor calculus and said nope. And said it's probably much more effective and practical to simply make these stars vanish. And here we can see again the orbital mechanics in effect as these stars begin to dance around a binary black hole system. Nope. That got noped. This one's getting noped. Left and right. Now what are these remnants here? I can't really click on them. There's something so eerie yet eerie yet compelling. I don't know what it is. Oh, look at these. We got... Wow, what the hell just happened here? Are these two stars that just exploded, or where did this nebula come from? What's going on? Well, back to the story behind what we're looking at is, so Schwarzschild was the famous contemporary, not as famous, but still nonetheless, he was soon to become famous, theoretical physicist. You might recognize the phrase Schwarzschild radius. But let's find out where that came from. How these gas plumes are actually very beautiful. Really cool. So he excelled in his abilities to deal with theoretical concepts. And when Einstein's articles on general relativity were published in 1915, Schwarzschild was one of the first to recognize their importance. But he was also a German patriot, so he set aside his astronomical studies when World War I erupted, and he enlisted in the army. Shortly before his death, though, he had contracted a life-threatening disease, so he was able to finally concentrate on completing his theoretical, physical calculations. And published his work titled On the Field of Gravity of a Point of Mass in the Theory of Einstein, which became one of the pillars. Look at that. I love watching it get bent. That's such a brilliant simulation. Look at that, 1 star becomes 2. It became one of the pillars of relativistic studies. And in it, Schwarzschild presented the solutions to Einstein's unfinished equations. Significantly, it provided support for a then seemingly implausible situation about the effects of severely compressed matter on gravity and energy. So when Einstein wrote his general theory of relativity, he found a new way, in fact, to describe gravity. It was not a force, as Sir Isaac Newton had proposed, but a consequence of a distortion in space and time, conceived together in his theory as space-time. Now, according to Einstein, matter and energy exist on a background of space and time. There are 3 spatial dimensions, as we can see, in 1 time dimension. As we could see if we were to pause everything and continue. I really love this kaleidoscopic effect of these clouds. Damn, this is so beautiful. Let's get a little more of that lensing. I really hope you guys are enjoying this too. By the way, I wanted to dedicate this episode to a big supporter of the channel, Hard Yaka, Steve. Yeah, because I have 2 Steves that are being really generous, and you guys are showing a lot of support. I wanted to differentiate you two using your username. But Yaka, you know who you are, and you and Scrappy both been a big support, big encouragement, big motivation, and just it's been really nice. It's really pleasant to hear that you're enjoying this. Oh, look what just popped back into frame here. So, I wanted to, you requested another Universe Sandbox episode, and I hope I'm able to do your request some justice by adding a little extra dimension and try to learn a little something about what it is we can play around with in the sandbox, so to speak. But regardless, this was a blast, and I just really appreciate that you enjoy my content, and especially one of these types of episodes, which probably only second to the philosophy are my favorite to make. So this was my pleasure, and I hope you, I really hope hope you and Scrappy enjoy it. So, what did Einstein do with his concept of a fluid continuum of space and time, 3 dimensions of space, 1 of time? As opposed to Newton's conception of a force, of mass and acceleration multiplying to give a force and interacting with other objects with mass. Einstein perceived the interaction of objects in space with one another as a, let's add another black hole. No, let's add some more stars. Let's go with a nice dim one. Is there a really red one? I don't see a really red one. But Einstein perceived it as objects distort the fabric of space-time based on their mass. More massive objects, of course, have a greater effect. Let's go with this one. Immediately gets warmed. That's the brightest one there is. Barnard star. There's a red main sequence dwarf star. Oh, I'm putting them in orbit. Okay. What's a binary? Now let's try to launch some stars. It's like potato launch, but with stars. Okay. What's with these stars? They're so tiny. Shoot. Oh, there we go. 260 suns. That's not a inconsequential mass. Oh, goodness gracious. Oh my god. And I just forgot that I launched that. I just launched that thing right at. Oh, that'll be fun to watch. So, just as a bowling ball placed on a trampoline stretches the fabric and then causes it to dimple or sag, so planets and stars warp space-time, a phenomenon known as the geodetic effect. So, here we go. Thus, planets orbiting the sun are in fact not being pulled. Oh, that's beautiful, look at that. And we still have this one in the background, dancing. So it appears that this one's in a relatively stable, helical effect. And this one got thrown over into the stars. Oh, it got eaten, of course. That was a cool dynamic. But the planets around our sun are not being pulled by the sun. They're following the curved space-time deformation caused by the sun. And do you know why the planets don't fall into the sun? Let me grab another gummy bear real quick. formation is due to the speed at which they're traveling. So, perhaps that's why the star is failing to get absorbed by this black hole, Sag A, which is over 4.3 million times the mass of our star. So matter tells spacetime how to curve, and spacetime tells matter how to move. So Schwarzschild realized the escape velocity from the surface of an object depends on both its mass and its radius. But if nature can make the radius of a given mass small enough, such as our black hole here, then the escape velocity, the velocity at which a particle needs to be moving to effectively escape the gravitational pull of these massive objects. Oh, I keep forgetting I'm launching these. Let's go binary. Okay. So it's the escape velocity is a very crucial concept in all of astrophysics, rocket science, cosmology. But if we have a black hole which is essentially so we've been inside a supernova the whole time, which is essentially an extreme of the most mass that can fit in the smallest area. Then the escape velocity will increase until it reaches the speed of light, which is the universe's ultimate static constant speed, velocity, time at which the fastest particle that we know of can travel between 2 points, which is 300,000 kilometers per second. Now at that point, neither the matter nor the radiation can escape from the object's surface. Additionally, atomic and subatomic forces become incapable of holding the object up against its own weight. Therefore, the object collapses into an infinitesimal point. The original object disappears from view, and only its gravity remains to mark its presence. As a result, it creates a bottomless with zero volume, but all of its mass as a singularity. We have two of them over here. Schwarzschild also explained that a singularity was surrounded by a spherical gravitational boundary that forever trapped anything that ventured within, and this boundary was called the famous event horizon. I should say the now famous, as he's the one who coined the term. Okay. He presented a formula that enabled the size of an event horizon to be calculated, and this is known as the Schwarzschild radius, as it marks the edge of the bottomless pit in space-time. You venture beyond this, you'll never return. Wow, so there's a lot of nebulae, a lot of supernovae that occurred here. I didn't realize that was what we were getting into, but I suppose that's how it played out. I love the perspective, and this is probably pretty accurate. That's just how large this looks like. Oh, good lord, sorry. And then we back out, and we zoom out, further out, and we get a scale of this cosmic size structure. And then we further zoom out, and we realize that this is nothing but a local phenomenon in this unimaginably expansive area in the universe we call the galaxy, the Milky Way galaxy, which itself, speaking of galaxies, oh, here we go. Let's just add a galaxy right there. What's going on here? Oh god, so we expand all the way out. Let's see if we can view the grid. There we go. So now we're in such large distances that our units switch from light years to Milky Ways. That's pretty comical, but true nonetheless. Just a cool 4.5 times 10 to the 11th suns. Goodness, where's that? Dark matter. They have dark matter here. What? What? What the heck? That's amazing. 2001 Space Odyssey. Pretty sure that's what just happened. This is so cool. I really don't ever mess with this program unless I'm recording, so I promise it's not a affectation of awe when I'm using this program. It's a genuine feeling of holy shit. This is actually something I could waste hours on. Okay. Let's add another. I'm getting a little bit faster at it too. Let's see. Okay, what's this? Is that 10 million? No, 1 million suns. That's 10 million. That's 4 million. Okay. Let's do 10 million, so it's a little bigger. Oh shit. It just ate that thing up. That was like a fox bouncing on a rabbit. No problem. So now we have a binary system. I'm gonna eat that star. I'm just gonna go around eating stars. Put it right there, right there. Oh my god, there's so many black holes now. So many black holes. They're everywhere. Need to add some stars way in the distance. Wait, what is this? Oh, we got Eta Carene. I'm gonna put Eta Carene. Eta Carene. Hey, way out there. And good old BSR J1311. Oh, he's a little guy, isn't he? And now we sit back and watch things get lensed. I love looking at that. God, that is so beautiful. I don't know why that is, but it is. Can I get rid of trails? Grid. Whoa. Okay. Oh man. Wow, it's late. I gotta get to bed. But I had fun making this. I hope you guys enjoy it too. Just black holes, man. Just hanging out. We had some stellar black holes. Some supermassive black holes. Some intermediate black holes. Well, as always, I appreciate all your support. I just genuinely enjoy and encourage you to give me positive, positively constructive criticism. Give me feedback. Let me know what you liked, what you didn't. If you're still up watching this, then I couldn't have been that good at giving you ASMR, but perhaps I just relaxed you for a nice afternoon snooze, which would be equally pleasant to have done. So if you enjoy this, then give it a like. Hit that dislike if you didn't, guys. Smash that dislike. Unsubscribe. Tell me why I suck. But if that's not the case, ways than interact and come visit me on my IG and my Twitter and let me know what you guys think of the channel. And throw out some suggestions. I love listening to it. I have a backlog of quite a few ones I already have to, I have planned that I intend to do soon. But your suggestions always help me, like I say, always steer my channel in the right direction. And your kind words are always welcome. I enjoy and look forward to interacting with all you guys, and I'll see you on the next video. I hope you guys sleep very well tonight. And before I let you go, I just want to give a personal thank you to Steve and Tim. You guys are awesome. I really appreciate you're just really encouraging, and it means a lot. You motivate me to keep going, and yeah, I just want to give you a really warm thank you, because that was so kind of you guys to support the channel the way you did. And of course, Ardyaka, you and Old Scrap, you guys are always a pleasure to chat with. I look forward to hearing what you think about this episode. And Jody, I want to thank you too. I was so happy to hear from you the other day. And you supported the channel, and you suggested for me to tap back into the comic books, which I'm really glad you did, because I actually just found a whole slew of old comic books. I guess that sounds like a lot more than it is. It's really only about 20, maybe less. But so yeah, you absolutely have that one coming right around the corner. And as for everybody else, Sandy, Potato Launch, Donna, you're awesome. I always look forward to your comments. Antoine, Sean, Andy, Josh, Alexander, thank you guys so much. Your support means everything to me right now, because, well, this channel's kind of on limbo right now. It's potentially going on a hiatus. I have a job shift coming up, and I don't know if I'm going to have the time to keep creating videos. So yeah, your support just really means a lot to me, and I just didn't want it to go unnoticed and unthanked and unappreciated. So what you did, what you've given already, is more than enough, and each and every one of you, just, it means so much that you guys would throw anything towards the channel. So it's just a pleasure. It makes me happy. So I wish you guys a fond farewell, a sweet good night, and a solid sleep. I hope you wake up refreshed, feeling good and limber, ready to tackle the day. Until next episode, sleep well, and do your best.